Chapter 16.4 How Confidence Intervals Behave. Ideally, when we construct a confidence interval, we want that interval to be as narrow as possible. Why? Because a narrow interval allows us to pin down the mu more precisely. Let's say we have these two intervals here, from 8 to 12, 4 to 16. Which of these intervals would give us a more precise estimate of mu? It's the top one, because it's narrower, it's less wide. Now, so the key question is, how do we get a narrow interval, or an interval as narrow as possible? Well, this is our formula. We take a sample mean, and then we give each side some margin of error. So imagine if I give myself a smaller margin of error on each side, then my interval will be less wide, right? Will be narrower. So the key question is how to get a small margin of error. We go back to the formula. We ask ourselves, in this formula, what are the things that I have control over? What are the things that I don't have control over? We say we don't have control over the sample mean because of randomness, and we don't have control over population standard deviation. It's kind of given. But we have control over n, the sample size. We can select a bigger or smaller sample. And we also can control the critical value, z star. Remember, the critical value, c star, depends on our level of confidence. If we are 95% confident, then z or z star is 2. So if we pick a different level of confidence, we will get a different z value. So we're going to investigate this in classwork. And then next week, we'll look at how the sample size affects the margin of error. So this is for next week. But today we're going to look at classwork.